In this video, I'm gonna use a integration by part, and let's first set u here. I'm gonna set u equal radical x, and that can be written as x to the 1/2. And if I take a derivative with respect to x and du, u actually, so you get du, and then 1/2 must be pulled as a coefficient, and then when you take a derivative, we use a power rule where the exponent is subtracted by 1, so you get negative 1/2. Okay? And then don't forget the dx. Alright, now here I'm gonna actually rewrite this for better visual. So I'm gonna get dx on the top, and then 2 times radical x. Okay, here I'm gonna use a special technique where I cross multiply on both sides, and then I'm gonna exploit the fact that I set u equals radical x, meaning this can be replaced with u. So let me first multiply on both sides by 2 times radical x. That way, this bottom gets cancelled so that on the right side, I only have dx. Alright, so on the left side, I know it might look weird because we have du and radical x, but just like I said, that u equals to radical x, so I'm gonna replace that radical x with u. So I get actually 2u. Okay, notice that they are equal. Alright, so I'm gonna replace dx with 2u du. Okay, here we go. This part is gonna be replaced with this part. And also notice that radical x is u. Okay. So I'm gonna just replace the first term u, because I know radical x is u, and e to the u again, and the dx is replaced with 2u du. Okay, notice that I have not fully used the integration by parts yet, but I want to demonstrate first by doing this, by cleaning up some mess so that it becomes easier. Alright, I want to pull the 2 in front of the integral using the law of proportion, proportional constant, I forgot. So anyway, you know that 2 can be pulled out, and then the u can be multiplied to make u squared, and then I have e to the u and du. Okay, so looks like I need to set this to be something that's u part, and that to be the v part. I know right now it might be confusing to you because I have a u squared here. Okay, that u, okay, remember that whenever you have a integration by parts like this, you have a uv minus let's see, v du. There you go. Okay, that's like the first term where you take derivative. Here you actually integrate, right? The first term I'm gonna set is, instead of u, because they can be confusing, I'm gonna set a. A equals u squared, therefore dA equals 2u du. So what I'm trying to achieve here is, instead of saying u and v, I will have av, and I will have a times v minus dA, integral v times dA. And if I call this a, I have to call this v, and I can use v because there's no confusion here. So technically you start with dv, and then you take the whole chunk on the right side, e to the u du. Well, now if you take an integral on both sides, you get VEU. Okay, one visual effect or memory mechanism is I tend to just group it like this first to displace that, and then what I do is I combine these, and they will be placed in the integral. So what I have is, don't forget 2 here, the constant. Actually that's wrong. Okay, u squared times EU minus, I get e to the u 2u du. I think I can write better by pulling out 2 outside. And then notice that if I do one more time of integration by parts, then everything will be solved like a charm. So let me first go down here. Okay, so I'll do integration by parts one more time. And of course, at the end, we have to write the answer in terms of x. So I'll show that later. But for now, let's keep everything consistently with u. 2 is outside, u is here, and then e to the u and du. I'm gonna set a again. So notice my focus is this part. We're trying to use the integration by parts one more time. I said a equals u, and thankfully the dA equals du. And the e to the u du, I'm gonna set that dv, and when I integrate on both sides, notice that v equals eu. Again, I'm gonna have this backslash a times v minus integral of v times dA. Set this equal u 2 times, I don't know why I keep putting the integral sign in front. Okay, u squared times eu minus 2 times u times u times eu minus integral of dA and du and EU. So EU du. Notice that we have 2 parentheses. One is being nested like that. So at the end, we have to be careful with the coefficient. So always start from the inner one. So we know that e to the u is e to the u in the antiderivative form. Therefore, I can write as u times EU minus EU like that. I think I have an extra parentheses. There you go. Okay. So now all we have to do, is multiply by the coefficient. However, don't forget that we still have a u equals radical x, which we'll have to replace them in the u at the end. Okay, so I'm just gonna distribute these like that and like that. Algebra 1. So 2u EU, okay, that's multiply, minus 2EU. Then you have u squared EU Notice that u squared here and then times EU is not like term 2u EU. They are not like terms, so you cannot combine them. However, I see the pattern that e to the u can be pulled out. So I have u squared minus 2u minus 2. Oh, there's something mistake here. So I have a minus sign here and then you have minus sign there. Okay, it's gotta be positive. I was like, that's kind of weird. Okay, you get the plus sign. Okay, don't forget that minus times minus become plus. Okay, so since this is a indefinite integral, you have to have plus c. And finally, you have to substitute the radical x. So it will be 2 times e to the radical x. And then when you square the radical x, it simply becomes x minus 2 radical x plus 2 plus c. And that's my final answer.